So in this problem, there are two expressions that we are asked to evaluate in which the exponent is 0, or at least one exponent is 0. So let's take a look at the first one. The first one says 2 times 2/3 raised to the 0. And this is based on the idea that if we have a numerical value, let's say x, and we raise that to 0, the value we get is 1. So if the exponent is 0, the result is 1, except in the case that x equals 0. X equals 0 raised to the 0 is undefined, but we generally don't see that very often. So let's take a look at the first one. 2/3 raised to the 0 by definition is 1. So we have 2 times 1. So that would just give us 2. The second one is -7 to the 0. Well, -7 to the 0 by definition is 1. So I'll go ahead and write this one out. -7 raised to the 0 is equal to 1. So one question might arise is if x to the 0 is 1, is -x to the 0 -1? And no, that's not the way it works. -7 to the 0 would also be 1. So again, the only exception for that is in the case where the number that you're raising to the 0 is in fact the 0 itself. Now this may seem like an odd calculation to do in chemistry, but it turns out it will come up in the second semester of chemistry. There are particular problems where we do have experimental data that works out that the exponent in the equation is a 0, and we have to understand this definition.